Welcome back to the classroom. My name is Mr. Wong. In today's lesson, we're going to go through the 2011 HSC physics paper, question 19. This is going to be about the photoelectric effect, so it applies to Module 7, inquiry number 3. We have a laser of light that has a wavelength of 550 nanometers. So again, we need to make sure we convert this into meters. Okay. The question's asking us to calculate the frequency of this light source. Yeah, so we can just use V equals H lambda in this case here, knowing that V is the speed of light, F is what we want to find, and obviously lambda is this value here. So F is just C over lambda, so equals to that over that. And so the frequency of the light that we get, if I just correct myself, is 5.4445 repeater times 10 to the power of 14 hertz. So that's what we have there. All right, then we move on to question B. And this one says the electron in a specific metal must absorb a minimum of this amount. So we can say that is the work function of our metal. Explain why electrons will not be ejected. So we want to explain why electrons will not be ejected if the photon has a wavelength of 550 nanometers. So that is exactly the same laser we're talking about here. And it says support your answer with relevant calculations, or with relevant calculations. So we know that in order for an electron or electrons to be emitted for the photoelectric effect, that the energy of the photon must be greater or equal to the work function. So that's what we have here. So the work function in this context is 5 times 10 to the power of negative 19 joules. We know what the threshold frequency, or we know what the frequency of our photon is. So energy of the photon is equal to Planck's constant multiplied by the frequency we just calculated. So I'll just do that, repeater, like that. So the energy I find was actually the number I miscalculated early on. And that's 3.614181818 times 10 to the power of negative 19 joules. So if I do that comparison there, the energy of the photon in this context is smaller than the work function of the metal, as 3.614 times 10 to the power of negative 19 joules is smaller than 5 times 10 to the power of negative 19 joules. So therefore, because we have a smaller amount of energy in the photon, therefore no photoelectrons will be emitted. Energy of photon is, go down a little bit, is smaller than the work function. And that's how you approach the question here as well. If you found this recording helpful, please like and subscribe, and I'll see you next time.